Today we talk about the new topic, theory of inference. Inference theory is concerned with inferring of a conclusion from certain hypothesis or basic assumption called premises by applying certain principles of reasoning called rules of inference. Rules of inference are the template for constructing valid argument. Valid argument. Argument is a sequence of statement that ends with conclusion. Argument means a sequence of statement. It can take the following form: S1, S2, S3 and so on, and finally we can reach the conclusion. So these statements, set of sequence of statement then ends with conclusion. These statements we can call it as premises. Okay, using this premises we can derive some conclusion. So that is argument. But valid argument means all the premises are true, then the conclusion is also true. For example, suppose we have the premises H1 P conditional Q, H2 P, then the conclusion is Q. So what is valid argument? Valid argument is nothing but set of all its premises are true, then the conclusion is true. So how we are going to construct a truth table for these argument? So already we know that if you want to construct a truth table, so first you are going to check how many proposition variables are involved in this. So we have two proposition variables P and Q. Therefore, the truth table contains two columns P and Q. How many rows the truth table will contain? Because 2 proposition means 2 squared. 2 squared is equal to 4. So 4 rows will be available, isn't it? So true, true, false, false, true, false, true, false. Okay, so what about your H1? Here H1 is P conditional Q. Already you know that how we are going to construct a truth table for P conditional Q. P conditional Q is the truth value of P is true and the truth value of Q is false. Then the truth value of P conditional Q is false, otherwise true. Isn't it? Okay, what about your H2? Your H2 is P. So you have to write the same truth value here. So your conclusion is Q. So what is your Q? T, false, true, false. Among this, the first row will contains, the first row is the only row in which both H1 and H2 have the truth value true and the conclusion is also true. So in that row only the valid argument is available. The remaining are all false, true, false. So what is the statement of a valid argument? A set of all premises are true, then the conclusion is also true. Therefore, how we are going to write this? H1 conjunction H2 logically implies conclusion. Logically implies conclusion means what we are going to prove? H1 conjunction H2 implication C is tautology. Tautology, isn't it? Okay. So rules of inference. Why we go for rules of inference? Because already we know that truth value. We can able to use truth value to check whether the given argument is valid or not. But sometimes truth table is not possible. For example, an argument involves 9 different propositional variables. 9 different propositional variables. So in that case, how we are going to construct a truth table? So already we know that truth table means it consists of column and rows. A column depends upon the number of preposition variables. Here how many preposition variables are involved? 9. So truth table will contains 9 columns. Isn't it? So how many rows the truth table will contains? 2 power 9. So what is 2 power 9? 512 different rows. So this will be very tedious to construct a truth table. 512 rows. So it is very not possible, isn't it? It is possible, but the work will be tedious. That's why we go for rules of inference. So we have 10 rules of inference are there. So here I will list out all the 10s one by one. The first one will be P, therefore the conclusion is P disjunction Q. The name of this rules of inference is addition. Okay, addition. So how we are going to write this? P logically implies P disjunction Q. That is P conditional P disjunction Q is tautology. Tautology. Already you know that tautology means all the truth values are true. Then only we can conclude that the given statement is tautology. Okay. Second, rules of inference. You should remember all these things. Here the set of sequence of statement is PQ. Therefore, the conclusion is P conjunction Q. So this rules of inference we can call it as conjunction. Conjunction. So you have to remember this. Third one, P conjunction Q. Therefore, the conclusion is PRQ. Here the name of the rule is simplification. Simplification. Name of the rule is simplification. Okay, and fourth one, P conditional Q. P, therefore the conclusion is Q. So this one we can call it as modus ponens. Modus ponens. So this is very, very important. Frequently we are using modus ponens rules of inference in the problem. Okay, fifth one, P conditional Q, negation Q. Therefore, the conclusion is negation P. So this one we can call it as modus tollens. Modus tollens. Modus tollens. And sixth one, P disjunction Q, negation P, therefore Q. So this one we can call it as disjunctive syllogism. Disjunctive syllogism. Seventh one, hypothetical syllogism. This also frequently we are used in the problem. P conditional Q, Q conditional R, therefore the conclusion is P conditional R. So this one we can call it as hypothetical syllogism. Hypothetical syllogism. Syllogism. Hypothetical syllogism. Okay. And eighth one, P conditional Q, conjunction or conditional S, and P disjunction R, therefore Q disjunction S. Constructive dilemma, destructive dilemma, and resolution. So these are the important rules we are going to make use in the problem. And two more additional rules are also involved in rules of inference. That is rule P, rule P, rule T, and rule CP. Rule P, that means rule of premises. Rule of premises. So already you know that premises means it's a statement. Okay. Assumptions or evidence, whatever it is. Premises, rule of premises. Rule T, rule of tautology. Rule of tautology. Tautology. And rule CP, rule of conditional proof. Rule of conditional proof. So what do you mean by rule P? So rule P means a premises may be introduced at any step in the derivations. Rule T. What do you mean by rule T? A formula S may be introduced in the derivations if the formula is tautologically implied by one or more of the preceding formulas in the derivations, then we can call it as rule T. Rule CP. What do you mean by rule CP? Rule of conditional proof. If the formula S can be derived from another formula R and a set of premises, then the statement R conditional S can be derived from the set of premises alone. So in other words, if the conclusion is of the form R conditional S, then take R as the additional premises and derived S using given premises and R. Okay, and finally you can write R conditional S. So these are the important rules we are going to make use in to solve the problem by using rules of inference.